Praisy from the second year Biomedical Department of ECE. Today I am going to present on Discrete-Time system, series versus parallel connections in the subject of biosignals and systems. Systems can be understood as the building blocks. Just like we combine small blocks to create complex structures, we combine systems to perform advanced signal processing. In discrete time system, there are two main ways to connect system: series connection, parallel connection. Each has different characteristics and applications. In this presentation, we will explore how discrete time systems behave when connected in these different configurations, examining their mathematical properties, practical application, and key characteristics that make each connection type valuable for specific engineering scenarios. In the series connection, systems are connected one after another. The output of the first system becomes the input of the second system. So the signal follows step by step through each system. The overall system behavior is the cumulative effect of each individual system characteristics, creating the component transformation for the original input system. To understand this easily, we can use the domino analogy. When one domino falls, it pushes the next one and the effect continues in sequence. Similarly, in series systems, each system affects the signal one after another. So the final input in the combination of all system affects. Series connection, mathematical insight. When we connect two discrete systems described using convolution, each system has the impulse response like H1 and H2. When combined, the overall response is convolution of these two. N of H1, N of K is equal to H1 of K into H2 of K. When connected in series, they combine impulse response by the convolution. This means impulse is filtered version of the input with the filtering characteristics of both systems combined. Individual system response. System 1 has impulse response H1 of K and system 2 has impulse response H2 of K. These responses characteristics how each system modifies an input signal. Parallel connection. Now let's move to the parallel connection. Here the same input signal is given to multiple systems at the same time. Each system processes the line independently. Input distribution, independent processing, output combination. The same input signal is distributed to system simultaneously. Its input distribution. Individual outputs are combined typically by summing them together is output combination. This combined output is blend of the individual system responses to the same input, allowing for simultaneous processing paths that can be weighted or combined in serious ways. Parallel connection. The mathematical description of parallel connection system remarkably straightforward compared to series connection. Identical output, individual response, summed output. Both systems receive exactly like the input x of k is the identical output when y1 of k is equal to h1 of k convolution x of k. System 2 produce output y2 of k is equal to h2 of k convolution x of k. Summed output is come with the plus symbol. The combined impulse response is simply the sum. H of k is equal to h1 of k plus h2 of k. Mathematically, parallel system is much simpler. Each system produces its own output and then we adjust them together. Emphasizes formula these types. So the final system response is just the sum of individual responses. Then we move on to the flow differences. In summary, series means signal flows step by step and in parallel signal flows simultaneously. This difference affects how signals are processed and combined. Input signal, then to go system 1 processing, intermediate signal, system 2 processing, final output. These are series configuration. And the parallel configuration, input signal, original signal x of k splits and goes to the both systems simultaneously. System 1 input y1 of k is equal to y1 of k convolution x of k. System 2 output y2 of k is equal to h2 of k convolution x of k. Then it goes to the combined output y of k is equal to y1 of k plus y2 of k. And the analogy equal stages. In the real world applications like audio processing and some other parallel connection systems, input audio of the microphone or instrument or tracks enters the processing chain as a signal. Filter 1, then each stage might remove low frequency rumble. In filter 2, the next stage refines the tone further. In this, additional stages continue shaping the spectrum until the response is reached. Final output is the filtering stages, creating cumulative frequency response. In the parallel connection setup, the input split into multiple parts and processed independently. This is audio mixers and multi-band processing. Input split, branch 1, branch 2 and mixes sum. Applications and importance. In the real world application like audio processing, series connection is used for step-by-step filtering. Parallel connection is used for mixing different signals. This helps in better control and flexibility. These concepts are very important in engineering and biomedical fields. For example, signal filtering, communication system, sensor data processing. They help in design efficient and accurate system. Key takeaways. Into conclusion, series and parallel connections are fundamental in discrete time systems. Series provide a sequential processing while parallel provides simultaneous processes. Both are essential for designing complex signal processing system. Both series and parallel connections are fundamental building blocks in discrete time systems that meet complex real-world requirements. In the simple, series means one after another, parallel means same time. Thank you.